Hello, my name is Mohammad Farajinejad and I'm going to speak about my presentation. It is about design and simulation of a grid-connected PV system to supply electricity of cabins and temporary housings in an oil and gas field. Here we can see the contents of my presentation, which include introduction, grid-connected PV systems, methodology and steps for designing grid-connected PV system arrangement and configuration, shading optimization, simulation result, and conclusion. At first, I'm going to speak about oil and gas field. An oil and gas field is a fast-track option for oil and gas production that allows firms to start production from the closest site to oil and gas wells, allowing oil and gas companies to put wells into production considerably faster than usual without the need for permanent infrastructures. It requires power for heating, cooking, washing, and for crews who dwell in cabins. Electricity source for oil and gas machinery and equipment is usually diesel generator with variable voltage. Grids in remote areas are usually not able to support the fast electrical demand, and it needs electricity with a fixed voltage level for cabins. Here we can see grid-connected PV systems. Grid-connected PV systems account for approximately all the world's installed solar energy capacity. PV systems that are connected to the grid and do not require batteries are less expensive and require less maintenance, supplement traditional energy sources, and improve renewable energy contributions to reduce carbon dioxide emissions. Flexibility, non-pollution, no noise, low maintenance, and ease of installation in any location with solar irradiation. Net usable energy production is affected by ambient temperature, solar irradiation intensity, rate of dust supplement on the solar system upper surface, and wind speed. The South Azadegan oil field near the city of Ahvaz in southwest Iran is a subject of this project. This figure shows the statistics from the PV solver database, which is based on the Meteonorm website, including horizontal irradiation, diffuse irradiation, temperature, wind, velocity, length, turbidity factor, and humidity. The region has a subtropical hot desert climate with long, hot summers and cool, short winters, according to data obtained from the Iran Meteorological Organization. Solar radiation is the rate at which the sun's radiant energy is impacted on a surface per unit area, and the hourly global solar radiation in a clear sky on a horizontal surface. Here we can see solar energy calculation. Solar energy applications are typically positioned at an angle rather than horizontally to enhance the quality of radiation intercepted and reduce reflection and cosine causes. These data must be covered to radiation on slanted surface. Here we can see the ratio of beam radiation on the slanted surface to that on a horizontal surface. Every device has a set amount of power consumption that can be found on its nameplate. In this table, load has been imported into PVSys solver as a daily load profile, which means that the total load consumption for each hour of the day has been described and the load graph for the system has been defined. Monocrystalline, polycrystalline, and thin film PV panels are the most prevalent PV panel types utilized in the design of major PV power plants. The type of panel used is influenced by a number of criteria, including available space, surface type, climate, and capital cost. The super high-power mono-PERC module, a product of Canadian Solar, was chosen as the PV panel for this project. It has a nominal maximum power of 450 watts and an operating voltage of 41.1 volts. For better understanding of the PV panel performance, the panel characteristic diagram is shown in this figure, which the maximum power of PV module in each incident irradiation is specified on the graph. In this slide, I'm going to speak about some criteria for inverter selection. Converting the DC energy produced by the array into the AC energy required by the grid, low total harmonic distortion of current, high power factor, low level of electromagnetic interference, high efficiencies for AC-DC conversion, and maximum power point tracking. The series and parallel arrangement of panels in a solar project is done in such a way that the input voltage and power parameters of the inverter are met. The following formula and calculation are commonly used to achieve this goal. The shading impact always is essential to be optimized in solar system design projects because shading can reduce output power and as a result lower system efficiency. The effect of shade has been avoided in this project by putting solar arrays at proper distances. Here we can see shading factor table. This table summarizes the key findings of the proposed solar system. The global horizontal radiation of the site location is indicated in the first column of table, and it peaks in June when a value of roughly 270 kWh per square meter owing to a shorter distance between the Earth and the Sun in June. This figure also illustrates the incident irradiation distribution for the PV system side, which most of the time is greater than 600 watt per square meter, which is appropriate for producing energy around the solar panel rated power. Here we can see incident irradiation distribution graph. And now we can see daily system output energy graph. This figure depicts the system's normalized production and loss factors, allowing users to see how much of the sun's energy is wasted due to the PV array and inverter before it is converted into power for the consumers. This figure depicts the system's loss diagram over the course of a year, which includes various losses that have an impact on solar system efficiency. For shading, near shading, and IAM factor on a global scale are the losses that occur before getting sun irradiation by PV panels. And in this graph, we can see average module temperature during running. The solar system's CO2 saving over its lifetime are depicted in this figure. As can be seen, running the solar system will save approximately 1089 tons of CO2, which will assist to combat global warming. Here we have conclusion. The grid-connected solar system has the potential to meet the required power of loads in remote areas where the grid is unable to support the total demand of large users who require electricity in a short amount of time for development plans such as oil and gas field units. Furthermore, grid-connected solar systems are far more cost-effective than standalone solar systems that rely on battery bank to store energy. By connecting to the grid, the system's reliability is improved and the likelihood of load losses is reduced. which is an important aspect of any electrical project, because battery banks account for a large portion of the cost in these projects. After completing the mission of the oil and gas field units project, the solar system can be transferred to a new facility location and provide electricity energy for new users with just minor modification.